resolution of forces, number 4 and number 5. So number 4, we've got a canal barge, which apparently has a mass of 1,000 kilograms. And we're told a force of 800 newtons is applied at a 40-degree angle, and we want to know the acceleration of the canal barge given that there is a frictional force of 100 newtons. So the first thing we do is find the component of the 800 newtons that is parallel to the direction that we want the canal barge travelling in. So that will be, yet again, F cos theta. So that will be 800 cos 40 degrees, which should give you 613 newtons. And then we want to find the unbalanced force. So that will be, the unbalanced force is the parallel force minus the frictional force. So that's 613 newtons minus 100 newtons gives us 513 newtons. And having got the 513 newtons for the unbalanced force, we can work out the acceleration fairly easily. A equals fun over mass 513 newtons over 1,000 kilograms gives us 0.513 meters per second squared. Now, in number 5, we've got a similar idea, but this time there are two forces applied. So, first off we need to do is work out each of the parallel components, because there will be a parallel component due to this force pointed in that direction, parallel to the direction we want it travelling in, and there will be a parallel component again pointed along this direction due to this force. So we've got two forces, both of which will have a component pointed in the direction we want it to travel in. So there's two ways of doing this. First we work out each one separately and double it, which is what I'm going to do now. So that will be, yet again, F cos theta, 120 cos 20 degrees equals 113 newtons. And then the total parallel force would be 2 times that, because there's 2 of them. So that will be 226 newtons. The alternative way of doing it is to go in at this stage and go F equals 2F cos theta, so T parallel. And so we're, instead of doing a doubling later on, we're just putting a 2 into the equation to begin with. And that will give us the same value. Either of these methods is correct. So whichever one pleases you, that's what you go with. For part B, we're given the forces have increased to 140 newtons. Okay, let's work out what our Ft parallel is. So that's 2F cos theta equals 2 times 140 times cos 20, and that should give us 263 newtons. And then I'm supposed to be using this to work out an acceleration. So I need to find an unbalanced force. Unbalanced force will be the 263 newtons that I've just worked out as the total of the two components of the two forces of 140 newtons pulling off to the right, minus the 226 newtons that I worked out in part A. Why am I taking away the 226 newtons that I worked out in part A? Because it said in part A that there was no acceleration. It was travelling at a constant speed in part A. That means that the unbalanced force in part A is 0 newtons. That means that the frictional force must be 226 newtons. And that's why I'm taking it away from the 263 newtons that I calculated in part B. And that's going to give me 37 newtons as my unbalanced force. And then I'm going to work out the acceleration. A equals F over M equals 37 over 100 kilograms apparently, which will give me an acceleration of 0.37 meters per second squared. And that's that one done.